All right, welcome everybody to our relations unit. We are powering through lesson 1, 2, and 3 in one day, so I'll try to keep this as short as possible. So this is just our review and preview. Hopefully you've seen these, a lot of this before in grade 8 or 9. So we are getting into graphing, and we are going to use graphs throughout the rest of the course. And so when it comes to graphing, we are going to use the Cartesian coordinate system. I think you are all familiar with it. You've all graphed on the Cartesian coordinate system before. It is like a graph that has a y-axis and an x-axis, or a two-dimensional system. So there's a couple of things that we want to discuss regarding these graphs. So we want to talk about the intersection of these two axes is called the origin. So the origin is right there, right in the middle. So if you hear me in class say, oh, start at the origin, that is the center of the graph, or where those axes meet. So if I scroll up here, you can see they have a great example of a graph below. So the horizontal axis is normally called the x-axis, and the vertical axis is the y-axis. And you can see they actually have values. So starting from the origin, which is 0, as we move to the right on the x-axis, we are getting more positive. So positive 1, positive 2, positive 3, positive 4, positive 5. As we move to the left, it's negative. Negative 1, negative 2, negative 3, negative 4, and negative 5. With the y-coordinate, or the y-axis, as we move upwards, the y values get positive. Positive 1, positive 2, positive 3, positive 4, and positive 5. You can see they've got 5 labeled there. And as we move down, we've got negative values. So from 0, it goes negative 1, negative 2, negative 3, negative 4, and they have negative 5 labeled there, which is awesome. The graph is broken up into quadrants, right? Sections of 4. And you can see that we've got 4 sections on our graph split by these axes. So we call them quadrants, and the labeling is a little bit weird. It's counterclockwise. So this is quadrant 1. And then we move counterclockwise to quadrant 2 over here, quadrant 3, and then quadrant 4, Roman numerals. Okay, we use coordinates to determine locations on the graph. So you can see there are a bunch of points on there. So let's start with A. So we are going to fill out these points. So A is right here. And in order to accurately describe where that point is, we are going to use ordered pairs, they're called. So we're going to write our ordered pair in form of x coordinate, y coordinate. So it's a pair of numbers. So if I wanted to explain to somebody where that A is on the graph, I would first say where it lies on the x-axis. So you can see that it is, maybe I'll use a different color, or maybe I'll just use my highlighter. Straight down from A, I cross the x-axis at 2. And straight across the y-axis, I'm at y is equal to 4. So that's how I would describe that exact point, 2 and 4, or 2, 4. That's the ordered pair, or the coordinates of that point. It's like Battleship. All right, let's do B. So the x coordinate for B is right here. So that's negative 1, negative 2, negative 3. And the y coordinate, well, B is right along the x-axis. So if I trace that over, I'm at y is equal to 0. So that is negative 3 and 0. Hopefully this is starting to make sense a little bit. If we do the C, so C coordinate is here, or the C point. So we're going to do the x first. So we're going to go up to the x-axis and we see it's at positive 6. And the y is at, well, what is that there? Let's count that. It's this one right here. So -1, -2, -3. -3. This is how we describe where points are on the graph. And you can do that for our D and for O. O is right in the middle. So that is the origin, and that would be x0, y0, 0, 0. That's definitely a point on there. And D, where is D? Oh, look at that. D is right here. So if I look at where that lies on the x-axis, I trace that up to the x, and I'm at 0. So the x is 0, and the y is -1, -2, -3. Write the coordinates of the point in the second quadrant. So the second quadrant, if we look, there is a point in the second quadrant, that is point E. So it's going to be E, and the coordinates of E are -2 in our x, and 1, 2, 3 in the y, -2, 3. Write the coordinates of point in quadrant 3. So it looks like F is in quadrant 3. So it's going to be -1, 2, 3, 4 for the x, and -1, 2, 3 for the y. Yay. So that is how you graph points. I know it's a bit of a highlighting mess there. It really is a lot more simple than my diagram makes it. So here it says complete the following table using positive or negative. So in quadrant 1, all of our x coordinates are going to be, so if we're just looking at this quadrant right here, all of our x values are going upwards, so those will be positive. And the y coordinates are also going up, so they are positive. Quadrant 2, our x coordinates are going downwards, so they are going negative. The y coordinates are still going upwards, so they stay positive. In quadrant 3, we are going this way. Our x coordinates are still negative, and our y coordinates are also negative. So it's all that right there. And then quadrant 4, our x values are positive, and our y values are negative. It's that quadrant right there. There you go. So whenever we do ordered pairs, these coordinates here, we always do x first and then y. Don't get that mixed up. Okay. Describing a pictorial pattern using a linear relation. So there are going to be some questions like this where we have a picture, so showing us this is their drawing of a toothpick here, and then we have this pattern happening. So picture 1, picture 2, picture 3. So it looks like in picture 1 we use 3 toothpicks to form one triangle. So there's a relationship here between the number of toothpicks and the number of triangles. So how many toothpicks does it take to form 2 triangles using this pattern? Well, we have 1, 2, 3, 4, 5. And then how many does it take to make 3 triangles? 1, 2, 3, 4, 5, 6, 7. Awesome. So we could sit and draw the 4th one if we want, or hopefully we're picking up on the pattern here that this one's going up by +2 every time. So we should be able to say, okay, well, if we wanted to make 4 triangles, we need 9 toothpicks. And if we wanted to make 5 triangles, we would need 11 toothpicks. Awesome. So what we've done here is we've used a horizontal table to create sets of ordered pairs or coordinates, right? So we are going to represent this data on a graph. So you can see I have my t-axis is right here, and my p-axis is the vertical one. And we can just say that each square is 1. And we start at 0. When we label these axes, we have to have consistent scale. I couldn't say, for example, this one is 0, this one is 1, that one's 2, that's 10, this one is 1,000,000, and this one's 1,000,001. You have to have consistent. It has to go up by the same amount every time. Let's erase all of that. So I go up by 1 for my triangle. For my toothpicks, I can also go up by 1. There we go. So represent the data from the table of values on the grid. So the first point is going to be T1. So I go to 1 on my t-axis. And number of toothpicks is 3, so I go up to 3 and make my point. The next one is T2. So I go to 2 on my t-axis. And then I go up to 5 on the p-axis. So 3, 4, 5. And then 3 T and P7, so go up to 3 on the T and up to 7 on the P, and then 4 and 9, and then 5 and 11. You can see that it is making what looks to be a line, but the next question says, explain why it does not make sense to join the points in a straight line. And the reason we don't join the points is because if we drew a line, so for example, if I were to draw a line, I'll just do one right here. If I were to draw a line there, what that line is saying is that there are values between 3 toothpicks and 4 toothpicks. There are values right in here. And there shouldn't be values in there because we can't have half a toothpick or 0.4 of a toothpick, right? We can have 3 toothpicks and we can have 4 toothpicks, but there's nothing there in between. So it's called, we'll get into it, but it's called discrete data. Discrete data. So that means like if you were doing a graph on the number of people, well, you can't have half a person, or the number of textbooks. You can't have half a textbook or a third of a textbook, right? It's going to be 1 textbook, 2 textbooks, 3 textbooks. So that's discrete data. The other type is called continuous data, but we'll get into that. Okay, so it says, describe in words the relationship between the number of toothpicks and the number of triangles. Well, it looks like it takes 3 toothpicks to form the first triangle, and then 2 toothpicks every time after that. So that one's a bit of a tough one, but you could say the number of toothpicks. Oh, before we finish this, let's have a look at the numbers. We're trying to relate the number of toothpicks to, or the number of triangles, sorry, to the number of toothpicks. So it looks like if we double our number of triangles, we'd get 6. And then if we add 1, we would get 7. If we double this number, we get 8, add 1, we'd get 9. So there's like relationships there. They can be really hard to spot sometimes, but the more you do this, the easier it will get. And I'll show you the mathematical way to make a formula that shows that. So the number of toothpicks is double the number of triangles plus 1. It says write an equation that can be used to determine the number of toothpicks if we know the number of triangles. So basically we're looking for an equation that is P is equal to something, right? We want a mathematical equation that says, well, the number of toothpicks is going to equal this based on the number of triangles. So we're looking for an equation that is P is equal to, and then we want to use the variable T in there somewhere, or I guess it's a big T. We're trying to use the variable T in there somewhere. So mathematically, when we do this, the easiest way is to start with the P values. So look at by how much is each P value going up? You see it's going up by 2 every time. So the easiest way to do this, especially with linear relationships, is what we're always going to be dealing with, is you take that value of positive 2, because we know it's going up by positive 2 every time, and you multiply it by, I shouldn't use little t, we multiply it by the other variable, in this case, t for toothpicks. So we know p is equal to 2 multiplied by t. And then we do a test point. Does this actually work? Well, if t is 1, so if t is 1, then we know p should be 3. So let's do a test. P is equal to 2, and then I'll put a 1 in where the t should be. Well, 2 times 1 is 2, and we know it should be 3. So what if we maybe added 1 to it to get to 3? Let's try that. So we'll go plus 1. And then we'll do a quick test point. P is equal to 2t plus 1. So when t is 2, p should be 5. So let's put a 2 in where there's supposed to be a t. 2 times 2 is 4, plus 1 is 5. So that works. And if you want, you can double check a couple other points to see if that works. But that's the equation right there that represents this data set and this graph. So now that we have an equation, we can use that. So it says use the equation to determine the number of toothpicks if there are 27 triangles. That means there are 27 triangles. T is going to equal 27. And we're trying to determine the number of toothpicks. So we're looking for P. So if we know T and we're looking for P, the value of P, all we have to do is take the equation, because we know that equation works for every value, and we just plug in 27 where there's a T. And then we can solve that. 2 multiplied by 27 is 54 plus 1 P. So 54 plus 1 is 55. So that means when we have 27 toothpicks, or 27 triangles, it requires 55 toothpicks to make that. Use the equation to determine the number of triangles if there are 83 toothpicks. So in this case, we are trying to solve for the number of triangles, and we know we have 83 toothpicks. So it's going to be similar to the question we just did. However, we know our formula is P is equal to 2t plus 1. Now we're going to put in a value for P. 83 is equal to 2t plus 1. And we want to solve for the t variable. So in order to do that, we have to use our algebra to get everything away from the t. First thing we want to do is subtract 1 to both sides, because 1 subtract 1 cancels. So now I've got 2t on this side, and I've got 83 minus 1 on this side, which gives me 82. Now the last thing I want to do is, well, it's 2 multiplied by t. I want to get rid of that 2, So I'm going to divide it. I do have to do what I do to one side, I have to do to the other. 2 over 2 cancels. So on this side of the equation, I'm left with t. And 82 divided by 2 is 41. So that means that if I have 83 toothpicks, I'm going to have 41 triangles. Cool. That's kind of it for this one. Please watch lesson 2 and lesson 3. I'm trying to go through them as quick as possible. Thanks for watching. Don't forget to like and subscribe.